All right. Before I teach you factoring, let me tell you what factoring is. When you have something, and you have done backwards factoring for a very long time.
I remember that.
If you have something like this, okay, that is in factored form. And if you think about what it means to be a factor, tell me what it means to be a factor. What is a factor of something? Right, so it goes into it evenly, it divides evenly. So if I wanted to write like 6 by its factors, then I could maybe do 2 times 3, okay? This is the same kind of thing. This is the factored form of, if I FOILed this out, x squared minus 3x plus 2x. I'm going to assume everyone remembers how to do that, and I don't need to do a refresh on that. So this is x squared minus x minus 6. This is the factored form, what we started with, okay? So you, in your math career this far, have taken the factored form and expanded it. But you've never taken the expanded form and factored it. And that's what we're going to be doing. Yippee! Okay. No, you'll be fine. You'll be fine. So oh, our happy thoughts are falling.
Oh, no.
It's ominous, right? All right. So there are several different methods of factoring and things. I need to talk to you about some terminology first. Then we'll jump into it. The first thing, that probably the most important term in factoring, is called. Good job. Greatest common factor. Tell me what that means.
It's the biggest factor that 2 numbers have in common.
The biggest factor that 2 numbers have in common. Don't get factors and multiples mixed up. Okay? Multiples are whenever you multiply by something each time. Factors divide. Okay? Guys, I see lots of laptops out. I need y'all to put those up. This is very, 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 very important. It's the biggest factor that they have in common. So, for instance, if I gave you want me to write that down? Biggest factor that they share. For example, let's say I have 12 and 24. Good job. Give me all the factors of 12. In other words, what all goes in, and let's start smallest up to biggest. 1, 2,
3, 4, 6, 12.
How about 24?
1, 2, 3, 4, 6, 8, 12, 24.
What is the greatest common factor of those 2 numbers?
Oh.
Come on. Does that make sense? What if I throw some variables in there?
No.
Everybody just said no in unison. Because that's going to stop it, right?
Nope.
Let's say I have, let's use those same numbers. Let's say I have 12x squared and 24x to the third. Now what's the greatest common factor?
12x squared.
12x squared. Exactly. Okay? So, do you need to move so you can see a little bit better? Go ahead. You can either move out there, you can slide your desk, whatever you need to do. You can sit at my desk if you want to. Okay, so the greatest common factor of these 2 would be 12x squared, okay? Because you can divide them both by x squared and not get a remainder, right? All right. What if now we're going to get into the factoring part of it. Let's say I have an algebraic expression that looks like this. And I said factor out the greatest common factor. So you already know what the greatest common factor is, right? When I say factor out, what I'm talking about is a backwards distributing kind of thing. Okay?
So you take your 12x squared and bring it out?
Absolutely. So bring the 12x squared out front. What would I need on the inside that if I distributed this through, I'd come back to what I had here? 1 plus 2x. Does that make sense to everybody? No? Let's do a couple more. In fact, let me put you a little note. Yeah.
No, I think I got it.
When you're asked to factor out the GCF, and I'll run an example alongside here. Let's say I have 3x to the third plus 12x squared minus 6. Okay? When we're looking for a GCF, actually, let's make that 6x. When we're looking for a GCF, we're looking for the biggest thing we can divide everything by without a remainder. So here, the first thing I want to do is I want to find the GCF of all the terms. Okay? You're absolutely right. 3x. Look at the coefficients. They're all divisible by 3, right?
Yep.
And then I want to take the most x's away that I can, but I can't take any more than what anyone has. You see what I'm saying? Like I can't take 2 away if it only has 1. So I want to take the most I can, but I can't take any more than what the least one has. So you all said 3x, and you're absolutely right. So here's what you want to do. When you factor it out, you write the GCF in front. So 3x. And then you divide each term by the GCF. Okay? Because we're backwards distributing. Distributing, we're multiplying. So if we're doing everything backwards, then we're dividing now, okay? So 3x to the third divided by 3x would leave me with what? X squared. Does that confuse anybody where the x squared came from? Y'all good?
No.
Okay, if you divide 3x to the third by 3x, what's left? In other words, what would you have to multiply this by to make it look like this again?
No, I got you.
Okay. How about the middle one? 4x. Does everybody see where 4x came from? 12 divided by 3 is 4. I got one x on the outside. I need another one inside. Minus 2. Okay? This is a basic form of factoring. It's factoring out a GCF. Okay?
So
And you have to be able to do this, yeah.
So you keep the first one, like the first, the lowest number, like 3x. Wait, so 3 goes into 6.
What do you mean you keep the
2
one?
times. Right?
Yeah, but what, Evan, what now?
Where's the 3x come from? Yeah.
The 3x is the GCF of these 3. So look at the coefficients. What's the biggest thing you can divide 3, 12, and 6 by? And then if you look, this one has 3 x's, 2 x's, and 1 x. So how many x's can I take away from everybody? Only 1, right? So that's why there's only 1 out. Let's look at one more. Make sure we're GCF pros. All right, let's say I have now everything's not going to have a GCF. I'm just showing you ones right now that do have GCFs. GCF it.
4.
4. Why am I not putting an X outside this time? That last term doesn't have an X on it. I can't take something away that's not there. Does that make sense? Okay, what's left when I take the GCF of 4 out? 4x squared Did you just say that's easy? So the method I'm fixing to show you to factor relies heavily on GCFs. At which every factoring method relies heavily on GCFs. Yes, that's exactly what it is. All right. Who said it? That's all you have to do. Follow along this sheet. Sometimes with the more, I won't even say the more difficult concepts, but the more important concepts sometimes, if I can, I like to print you out a sheet so you can follow along and not be so frantically writing. And sometimes it helps a little bit. And then the second sheet I have, we're going to do together. We're going to factor them together. But I didn't want you to, I would have put it on the back, but I didn't want you flipping back and forth to try to see the steps. All right, so step one, and there's an example, as I'm sure you have found my style is now, is to do the steps on the left and the example on the right. So there's an example along the right. The original problem is 12x squared plus 14x plus 4. So step one of factoring is always, always, always to check for a GCF before you start. Okay, can I take something out of everything before I even get started?
Yes, which one, yes?
Yes, a 2, right? If you take the 2 out, let's write what's left. Factor the GCF out. What's left in the parentheses here? 6x squared. All right. Step one. Everybody good? Step two, list A, B, and C from inside because we're factoring quadratics now. Okay, this is going to come out to look like the 2 sets of parentheses like I showed you at the beginning. So looking at this one, what is A? And what is B? And what is C? Everybody confused? All right. Here comes the puzzle. I like to think of these as puzzles because in my opinion, this is the hardest part of factoring. Take the first number, the A, and the last number, the C, and multiply them together.
Wow. I remember doing this. The end of the year last year.
I'm going to show you why. All right, so here's what we're going to do. Here's the puzzle. I need 2 things that multiply to 12, but add to 7. Add to what's in the middle.
Yeah, we did a little bit of
Think about everything that multiplies to 12. 1 and 12. 6 and 2. 3 and 4. Of all those, which one adds to what's in the middle? 3 and 4. So what you're going to do now is you're going to rewrite 7x as 3x and 4x. Okay? It's going to have the same value. I'm not changing anything. I am literally just writing, yes. You know how whenever you FOIL, you have those 2 x terms in the middle that then you combine like terms? Yeah. Remember, we're backwards FOILing. Here's those 2 x terms. I'm breaking them apart now. Okay? It still has the same value. Nothing is different. I've just written 7x a different way. Okay?
But why would you want to extend the equation?
I'm fixing to show you.
Wait, but why would you put x on both of them?
Because they're both, what is 3x plus 4x?
Second?
That's when you multiply. When you add, you keep the exponent. It's just combining like terms. All right, is everybody with me?
It seems like we just got the GCF out and then like putting it back on.
It's still on the outside. But now I'm setting up for more GCFs is what I'm doing.
There's 2 terms.
Okay. That's right. So now what we want to do, some of you have this look of pure frustration on your face when we haven't even got through it. I promise it'll all come together in the end, okay? This, believe it or not, is the hardest part of factoring. And once you get that part down, the rest is smooth sailing. All right. As I look at just what's in parentheses, that 2 is going to keep carrying down. It'll be in my final answer, okay? So ignore it for right now and look at what's in the parentheses. I want you to think about this as 2 separate problems. Sometimes I'll even draw a slash in the middle, okay? Of the first two terms there, 6x squared and 3x, do they have a GCF? What is it? 3x. All right, so the 2's still there. Remember, ignore it. Don't worry about it right now. If I take a 3x out of the first two only, what does that look like?
3x, and then a bracket, and then 3x,
If I just came off to the side and I said, hey guys, I have 6x squared plus 3x, factor out the GCF.
You put that right there, the one inside.
Right. I'm just embedding it in the problem. Don't let it, because of how it looks, don't let it confuse you. Yes, ma'am?
So the great problem with plus and minus is square root.
Yes. Oh. I'm fixing to show you. It'll make sense. I'm going to show you. I'm a little bit confused.
Yeah, take that.
Oh my
So
God.
I got
Hold on, guys. I'm going to carry down this first sign, which is a plus. It's always easy when the middle sign's a plus, okay? We always want the middle sign to be a plus. All right, now do the same thing with these two. 4x and 2, does it have a GCF?
Yes.
What is the GCF? 2. What is left? I have the same expression. I have not changed any values. I have just written them another way. Okay? Now, I want you to think about something with me for just a minute, because this is the part that's going to confuse you if anything does. If I have something like (3xy) plus 2y, and I told you to factor out the GCF. And actually, I wanted this to be 3xy. What would the GCF be? Y, right? No, y would be the GCF. Okay? If I'm looking at this, do you agree that this might have two pieces to it, but this whole thing is being multiplied to 3x? In other words, 2x plus 1 is a factor of this term, yes? Yes. 2x plus 1 is also a factor of this term. Right. So if I look at it a little bit broader, 2x plus 1 is a greatest common factor of this and this. The same way y is a greatest common factor of this and this. So when you take it out, you always write it one time on the outside and put what's left inside, right? That's what I'm going to do then. I'm going to take, the 2's still there. I'm going to take the 2x plus 1 out. And I'm going to leave the 3x plus 2. And it's fact.
That's the end of this.
Because I had been carrying parentheses down, I left them. You don't need the second set of parentheses because multiplication is commutative and you can do it in any order you want. So you could really write this as 2x plus 1. There you go. Yes, ma'am.
After, like, when you do this, what do you have to do with it after?
Oh, we're going to do tons of stuff with this. This is kind of laying the groundwork to do the rest of Algebra 2. Yes, ma'am. Let's look at number 1 on here. X squared plus 6x plus 5. You're going to get so familiar with factoring that some of these you're going to be able to look at and factor without doing any work with them. That won't be today.
I think I'm gonna have to learn another way.
I can show you. I'll show you later. All right. As I look at this one, okay, is there a GCF I can take out?
No.
No. 1, well, and in the first, and I did tell you that, but in the first step, if it's 1, go on and just skip, okay? All right, so I want to multiply A and C together, yes? First and last, 5 and 1, so 5. I need two things that multiply to 5, but add to what? 6. 5 only has two factors, right? 5 is a prime number. So 1 and 5 are my two numbers. So I'm going to rewrite 6x as 5x plus 1x. Is anybody confused? Yes, ma'am. Okay, sure?
Asking there was, if you could also put one in.
You can.
Is it cool if we put 1x before 5x?
Yes, yes. Because the only thing that's going to happen is our factors will be flip-flop when we're done. Yours will be backwards from mine. But multiplication is commutative, so it doesn't matter the order that they come in. So it's fine. All right. Let's look at two separate problems here. I always call these slashers. Look at the first two. What is the GCF? X. If you take x out, what is left? Carry the first sign down. Everyone now. What is the, bless you by the way, what is the GCF of x plus 5? 1. It doesn't have one, so I hold it with a 1. What is left? Now, do you see an overall GCF? X plus 5. So factor it out. Oh, I hear a couple of people going, oh. X plus 5. X plus 1. That's the answer.
Oh my goodness.
I got it.
Yay! Some of us are getting it. That's okay. It takes practice. I promise. That's okay. That's okay. How might I check this, by the way, before the
Factor it back
foil
out.
it? Foil it out, and it should come back out to this. So no, because what happens is you took this out as a GCF, and so this is what was left. Not today. We will get to it. That's chapter 2. He asked about exponents, negative exponents. All right, so looking here, does it have a GCF? Other than 1? No. Multiply the first and the last together. I need two things. Now think about this. If I'm multiplying to a negative number, and I want two factors, one's got to be negative and one's got to be positive. Oh, can you see from the angle like this? I'm not hurting your head.
A little bit. It's good though.
You sure? You
Yeah,
can sit at my
I do-
desk. You can get that chair. You can
I do
move your.
neck rolls.
You can twist that desk around if you want to. All right.
My neck is hurting.
You can go sit there. Okay. What multiplies to negative 12 but adds to negative 4?
Negative 6.
Negative 6 and 2.
All right. So listen, because this is where.
Used to have 1 negative.
That's correct.
So there's like
So
twice
it's
as
negative
many
6
as
and
their normal.
Negative 6.
Come on, Pen.
Wait, so would that mean like basically there's twice as many?
You are absolutely right. So look, I'm going to list these factors out just to show you.
Just do it on purpose.
In order to multiply, the only way to get a negative number, when you multiply two things is if one of them is negative.
That'd be the greater number, right?
No, not always the case.
Look what it's got to add to. What does it have to add to?
Negative 4.
Negative 4. So of these, which two add to negative 2?
Negative 6.
The second
I'll
set.
remember doing
I told you this is the hardest part, is finding those two factors that work. So I'm going to rewrite negative 4x as plus 2x and minus 6x.
So you do put that number on the end after.
It's got to multiply to a negative. So I need one positive, one negative. Two negatives make a positive, two positives make a positive, right? So I listed all the factors, but I doubled them up because I know I need one negative, one positive. These two add together to positive 4. I need a negative 4.
Is there more than one way to solve this?
Is it what?
Is there more than one way to solve it? If you switch the two, is it a
Um,
different answer?
It would be the same thing. Your factors would just be, so like if you look back at the other, if I had flipped up here, it would have just given me x plus 1, x plus 5. It would give it to me in a different order. So it doesn't matter. The question was, does it matter which factor comes first as you rewrite it? And the answer is no. Is it the easiest way? I don't know that there is an easy way to do it. When I learned factoring, when I was in high school, my teacher taught us guess and check. And there's a lot of teachers that still teach it like that. Which means you set up two parentheses, you put two things here, and you start foiling out until you find the ones that work.
Oh, that's not easy.
Sounds like something else.
Okay, it's definitely something you don't want to do. Okay, looking at my, let me get back to my factoring here. I'm down to my 4 terms. I'm ready to slash it and look at it as 2 different problems. This one is different. Make yourself a note because this one has a minus in the middle, and that's going to make a difference. Okay. Look at the first 2 terms. What is the GCF? What's left? Now, that middle sign has to stay.
But then that brings up a problem, because then it's different.
What is, you're absolutely right. Look at this. What's the GCF here? 6. So what I have to do is I have to take out a negative 6. Okay? Because of that minus sign in the middle. So here this leaves me with x, but how about that last term? Plus 2. Because if I distribute negative 6 back through, that negative will pop back up.
So we have plus 2 and x minus 6.
Yes. See, I told you.
This is bad, but I already
I want you to try